My name is Hari Krishna. I am going to create a playlist covering majority of the topics present in B.Tech Deep Learning course. The main idea behind creating this playlist is to share the knowledge I've gained in a simple and easy to understand manner. The topics that I will be covering in this course are Introduction, Applied Math and Machine Learning Basics, Probability and Information Theory, Numerical Computation, Machine Learning Basic Algorithms, Deep Feed-Forward Networks, Regularization for Deep Learning, Optimization for Training Deep Models, Convolution Networks, Sequence Modeling Recurrent and Recurrent Nets, Practical Methodology, Applications of Deep Learning Research, and Deep Generative Models. And the subtopics I'll be discussing are Introduction, Historical Trends in Deep Learning, and what is Deep Learning in general. In Applied Math and Machine Learning Basics, I'll be discussing about linear algebra, scalars, vectors, matrices, and tensors, multiplying matrices and vectors, identity and inverse matrices, linear dependence and span, norms, eigen decomposition, singular value decomposition, the Moore-Penrose pseudo-inverse, the trace operator, the determinant, and principal component analysis. In probability and information theory, I will be discussing about random variables, probability distributions, marginal probability, conditional probability, the chain rule of conditional probabilities, independence and conditional independence, expectation, variance and covariance, useful properties of common functions, Bayes rule, information theory, and structural probabilistic models. In numerical computation, I'll be discussing about overflow and underflow, Fourier conditioning, gradient-based optimization, constraint optimization, and linear least squares. In machine learning basics, I will be discussing about learning algorithms, capacity, overfitting and underfitting, hyperparameters and validation sets, estimators, bias and variance, maximum likelihood estimation, Bayesian statistics, supervised learning algorithms, unsupervised learning algorithms, stochastic gradient descent, building a machine learning algorithm, challenges motivating deep learning. In deep feed-forward networks, I'll be discussing about learning XOR problem, gradient-based learning, hidden units, architecture design, backpropagation, and other differentiation algorithms. In regularization for deep learning, I'll be discussing about parameter norm penalties as constraint optimization, regularization and under constraint problems, dataset augmentation, and noise robustness. In optimization for training deep models, I'll be discussing about challenges in neural network optimization, basic algorithms, parameter initialization strategies, algorithms with adaptive learning rates, approximate second order methods, and optimization strategies and meta algorithms. In convolutional networks, I'll be discussing about the convolution operation, its motivation, pooling, variance of basic convolution function, structured outputs, data types, efficient convolution algorithms, random or unsupervised features, the neuroscientific basis for convolution networks. In sequence modeling, recurrent and recurrent nets, I'll be discussing about unfolding computational graphs, recurrent neural networks, bidirectional recurrent neural networks, encoder-decoder, sequence-to-sequence architectures, and deep recurrent networks. In practical methodology, I'll be discussing about performance metrics, default baseline models, determining whether to gather more data, selecting hyperparameters, and debugging strategies. In applications of deep learning, I'll be discussing about large-scale deep learning applications, computer vision, speech recognition, natural language processing, and other applications. In deep learning research, I'll be discussing about linear factor models, autoencoders, representation learning, structured probabilistic models for deep learning, and probabilistic models. And in deep generative models, I'll be discussing about Boltzmann machines and types of Boltzmann machines, and also generative stochastic networks. If you like this video, please like, share, and subscribe to my channel. Thank you.